Welcome back. I'm going to do the readings and the video summary a little bit differently for Module 3. Primary reason being that there's a lot of material. And if you read Pearson, you're going to be reading 60 plus pages and then watching the video lecture. And I think it's a little too much. And the material is really not well organized in Pearson. So I'm going to try to present this PowerPoint, which will take the place of the readings. It will contain all the information and do the lecture at the same time. And hopefully this will reduce the amount of time that you have to spend going through the material and make it much more focused and more clear. So this video is going to be a brief review of what we've been talking about. We're going to talk about what quantitative variables are, and we're going to go through what the basic steps of EDA is and what the purpose is. And then we're going to talk about why we're performing exploratory data analysis for a quantitative variable. And this is important. This is something that a lot of people really lose sight of when they're doing data analysis. They just make plots and compute numbers and don't really know why they're doing it. And that's important. That informs or helps guide and direct what it is you're going to be doing. Then I want to go through the 4 steps of how we do exploratory data analysis for a quantitative variable. So just like we did for a categorical variable, we have the same steps. We're first of all going to inspect the data, but we're going to find that at every step, quantitative data is more complicated than categorical. And even in the data inspection, we're going to see that understanding what is an outlier and what is an invalid data value can be tricky. Then we're going to plot the data. So we're going to look at the different types of plots we can make. Again, unlike categorical, we were essentially plotting the same thing. We were plotting counts or percentages just in different ways visually. We're going to see that these 3 graphs we can make present different information about the data set. And they essentially correspond to different levels of resolution at which we want to look at the data. And we're going to take away 3 main things from this plot. So we're going to want to talk about how do we describe the shape of the plot, the number of modes, and outliers. And now outliers are going to play a much more important role, whereas with categorical variables, it didn't even make sense to talk about outliers. They don't exist with categorical data. Then we're going to talk about summary statistics. So now we've visually summarized the data. Now we want to take the actual values, do some number crunching, and compute some statistics. And we're going to see that we don't compute any old statistics. We're going to compute 2 statistics that help describe key features of the plot. We're going to compute one number that represents the center of the data set, and it's in quotations because we're going to see that we have to really understand carefully what the center of a data set is. We're going to compute then a second number that characterizes how spread out the data is. And then lastly, we're going to put everything together. So we're going to use these 3 pieces of information from the visual summary, the plot, and we're going to use the 2 statistics that we computed and give a complete description of the data set. Okay, so our first video here is just going to be a really brief review. And what I want you to do is I want you to go ahead and download the following the following data set. So you click here, it'll open up a Google Sheets, and you can download this to your computer, make sure you know where it's saved. Not a bad idea to have a dedicated folder just to save the data sets in this class because we're going to use some of them later on. Then go ahead, open up StatCrunch, and import this data set into StatCrunch. And if you're not sure how to do this while you're pausing the video, you can go back and watch the videos that I posted on our Canvas course homepage that tell how to do various operations in StatCrunch, one of them which is importing a data set. So you can pause the video now and do that. All right, we're back. So now we want to talk about what is a quantitative variable as a brief review. Remember, this is a variable that measures the amount of something. One of the cool things in statistics is that words in statistics sound like what they are: quantitative, quantify. They're usually very easy to identify. First of all, quantitative data has to be numerical. Of course, that in and of itself does not necessarily constitute a quantitative variable. We know that categorical data can also have numbers too. So what separates the two? Well, generally quantitative data either is a physical measurement or count data. In other words, we're measuring some physical quantity like pressure, height, temperature, length, or we have count data, number of students in the room, number of cars in a parking lot. And the overall characteristic of both of these is that they have units. So count data has units. There are 29 cars in the parking lot. Each one is a unit, one car. Times when they're less easy to identify when we have rates or percentages. But again, I want to point out that even in these two cases, we have units. Okay, like right now, people are talking about COVID. How many cases per 10,000 people? There's units there. A percentage also has units. Even though we don't write it out explicitly, it's percentage of the whole. We're not going to deal a lot with these two, although when we start talking about the analysis of categorical variables, believe it or not, we're going to deal with percentages, because what do we do with all of the data from a categorical data set? We compute one number, a percentage, and we're going to see that we're going to want to analyze that percent later on. So the summary statistic that we compute from categorical data is also quantitative. So this is a really important type of variable to study. So some examples, okay, pretty straightforward. And at this point, I'm assuming that everyone probably has quantitative variables down pretty well now. So what I want you to do is to look at this data set, and we're going to do a little bit of, contextual background here. So first of all, who are we looking at? Okay, who are these things that are in our data set? So this is data that is taken from all F-16 fighter jets from 1986 to 2016. Okay, so these are the individuals in our sample. What are we looking at? There are two variables. There's actually year also, but year is more like an identifier, okay? There's the number of Class A accidents that occurred in a given year, and changes is the number of cockpit modifications that were made to all the F-16s that year. Why did this person do this? Okay, so first of all, F-16s can have really catastrophic accidents. They're terrific jets, but they can be a little unstable, right? So Class A accidents are the most serious type of accidents that a fighter jet can have. And what they wanted to see was whether or not the cockpit modifications had an effect on the Class A accident rate. Notice this is a tricky question, right? We're looking for cause and effect, and we know that this alone is not going to be able to tell us cause and effect, but it's going to be the first indicator as to whether we should pursue it further and try to investigate whether there's a cause and effect relationship. But right now, we're only going to see if there's an association. Okay. So how I got this data set, this is data set that was actually provided by an Embry-Riddle student, and he was doing his master's thesis, and I helped him out on his research. And so this is the data set that we used. All right, so now we know all the background. Now we're ready to get started, okay? So the first thing we do before we go into a full-fledged analysis, right? Our question is there a relationship between the number of Class A accidents and the number of cockpit modifications in a given year? Before we can address that, we look at each of the variables separately. First, we want to just explore them. And so we want to see, what are these Class A accident rates like? How many accidents can I have? Do I generally have 1 to 2? Can I have 100? We want to get a sense for what the data is like, okay? Okay, so when we're starting to look at the context, one of the things we want to think about also, and this is a tricky question, is do we have a population? When this student was doing his analysis, he came up with a very important observation. He said, I have all the data on all the F-16 fighter jets. So why am I doing statistics? That's a very good question, because if you actually have everyone in the population, you're really not doing statistical inference. You're just computing numbers and that's it. So does he have a population? This goes to the question of why is he doing the analysis? If all he wants to do is just a retrospective study and only wants to look at what happened in the past, he's not really doing statistics. He'll compute some numbers and really that will be it. But notice the goal is to use this in the future. So we're interested in all F-16 fighter jets under all different conditions. And so the accident rate, the variable we're interested in, is highly multivariate. In other words, it's affected by a lot of different variables, right? And there's a ton more that I could write here. And he doesn't have data on every pilot under every weather condition, under every age, fatigue level, et cetera, et cetera. So he doesn't actually have a population. He has a snapshot of the population. Why is this important for you? It's important for you because very often you will get data from the internet in which you have all the information from, say, a given year or up to a certain time. And some people think, well, I'm not doing statistics. I compute a number and that's my answer. And again, the relevant issue here is, are you going to use this in the future? Do you want to start making predictions in the future and things of this nature? And if you are, you don't have a population. You just have a snapshot of the population in time. This is an important issue that gets swept under the rug a lot. Okay, so let's go back to our big picture, okay? So we know what our population is, okay? He didn't really have a sampling method. He literally took a census in this case, okay? So he has all of the F-16s. He got them from the Air Force database. And now we want to use this data to learn something about the population. So again, I go back to this mantra. We keep coming back to this same theme. Samples estimate populations. I want to say something about the population from the sample. And this is where we start this process. So how does this come into play? So I'm going to show you a different example here, okay, to try to illustrate it because it's a little easier with this particular example that I've kind of jury-rigged here. So this is the percentage of heads we would get if we flipped a coin 30 times. And this was an activity in one of my classes. So I had a gazillion students each flip a coin 30 times, and they noted the percentage of heads. And here what I'm doing is I'm making something that we're going to talk about later. It's a histogram. It kind of looks like a frequency bar plot, okay? So these are the percentages, okay? So these are the percentage of people that had, say, between, I don't know, I'll just make up a number, 32% and 38%. Okay, and this was a number that got between this percentage of heads. And there were 8 people here that had percentages in this range and so on. So these are estimates taken from a whole lot of samples. And what we're trying to do here is the following. Okay, so these are the sample percentages from 90 students that I plotted. What we're trying to do is we're trying to fit this sample data, which is always going to be choppy, to a nice smooth curve. And that nice smooth curve is the curve that we think the population would fit. In other words, if I had not 90 students, but I had 10 million students, and they all flipped a coin 30 times, and we recorded the percentage of heads for each student and plotted it, it would begin to approximate in the limit of the number of students going to infinity, okay, it would begin to approximate this nice smooth curve. And that's what we're trying to do with the plot. We're trying to take our sample plot, which is going to be kind of choppy, and we're trying to fit it to a nice smooth curve, which we think comes from the population. So this is the goal of exploratory, well, I should say this is one of the goals of exploratory data analysis for a quantitative variable. But this is what we're trying to do with the plot here. And we're going to see as we go on in the course how this comes into play and why this is important. Okay, brief review of exploratory data analysis. It's a way that we get information from a data set. And we always do the following 4 steps. We examine the data, we plot the data, we compute numbers from the data, and then we combine the plot and the numbers to give a complete description of the data. And in the next 4 videos, we're going to look at each of these steps and see how we actually perform them, what we do, and how we carry out these operations using StatCrunch. Enjoy.